Okay, now see here. Can you see the board now? Yeah, you should be able to see it. Now this reacts. Rx plus sodium acetylide gives you R C triple bond C R dash. Okay. Now see, what is this? This is an acetylene derivative. This, of course, we are going to study this later, but see here, this is acetylene, carbon with a hydrogen and a hydrogen, ethyne or acetylene. This is called ethyne or acetylene. Now this one, if you react this with sodamide, sodium amide, this is prepared from sodium in liquid ammonia. Sodium is reacted with liquid ammonia, liquid NH3. You'll get sodamide. If you react this NH2 minus will capture this proton. See this. So it forms C triple bond C minus. Look at the mechanism what we are writing. This NH2 minus is NH2 is taking this proton. This is NH2 minus. There are two pair of electrons, and this is Na plus. So this takes this proton, and it forms a sodium salt of the acetylene, Na plus ammonia gas is evolved in the reaction. And this is a white solid. And now, if your starting material is instead of H, you have R. Suppose your starting material is containing R here, then this will be R. Okay. So that is what you are taking here. And that is what you are reacting with an alkyl halide. And see here you are forming a CC bond. A CC bond formation. A CC bond formation. Right? So this that way it is an important reaction. Similarly, if you take an alkyl halide Rx and react with ammonia, you will get you can guess the product. You will get RNH2 plus HCl. Okay, RNH2 plus HCl. What has happened is one hydrogen is replaced by R. One hydrogen is replaced by R. Now, you suppose you contain the reaction mixture contains more amount of Rx. Then what will happen? One more hydrogen will be replaced. You will form R2NH plus HCl. This you can go further. How far it will go? R3N plus HCl. And what about this one? Further this can go. This can further go. How? By, see, you have a lone pair of electron. You will get N This is a quaternary ammonium salt. This is a quaternary ammonium salt. See here, Cl minus. Okay, that is quaternary ammonium salt means just like ammonium chloride. See, ammonium chloride is what? This is ammonium chloride. H plus Cl minus. This is what you get when you react with ammonia with hydrogen chloride. Similarly, you have the triethylamine reacting charge X. So instead of H, instead of all this H, you have R. So this is quaternary ammonium salt. This is water soluble. So you can see here a primary alkyl halide is converted into primary amine. Primary amine. This is a secondary amine. Amine. A-M-I-N-E. This is a tertiary amine. And quaternary ammonium salt. Quaternary ammonium salt. Okay. Then, so that is more quaternary ammonium salt. You can all of these. You can write specific example. You need not write all this. Okay. Yeah. You can write specific examples. You can take you can replace the R with a CS3. So I not repeat the same thing. You can replace all the R by CS3 and give specific example as your answers. Now next, let us take. Now suppose I react this. Let suppose I take your RX RCl. I take RCl and react with potassium iodide. React with potassium iodide. What will you get? You'll get Ri plus KCl. Okay, suppose you're written, something is written like this, see, Ri plus KCl. What will be the product? You expect the reverse thing to happen. You expect the reverse thing to happen, right? You expect RCl plus potassium iodide. Now the question is which reaction will occur? Will the forward reaction occur? This is the backward reaction. This is backward reaction. This is forward reaction. Which reaction will occur in equilibrium? That depends on the nature of the stability of your product. Stability of your product. here potassium chloride is highly stable than potassium iodide. Potassium chloride is very highly stable than potassium iodide. So that way you can judge which direction the product will be formed. Which direction the product will be formed. Since potassium iodide is less stable, it will generate I minus a lot. And I minus is a very good nucleophile. It can attack here and remove this. But here, Cl minus is not a good nucleophile. It's a weak nucleophile compared to I minus. Okay, Cl minus is not a good nucleophile and therefore forward-backward reaction does not occur. Okay? So, forward reaction occurs. Clear? So, similarly, suppose you are taking RBr. You take RBr. Again, reacts with potassium iodide. You'll get Ri plus KBr. Okay. So Cl and Br, Cl and Br can be replaced by iodides, potassium iodide. So these are the general substitution reactions. Let us look at the mechanisms of these reactions. First one, there are two types of mechanisms which I have already mentioned here. Yes, I have mentioned. Let us look at first SN2 reaction. Okay, bimolecular reaction. Look at SN2 reaction. There are certain characteristics of SN2 reactions. Number one, kinetics of the reaction. If you perform the SN2 reaction, if your reaction is SN2, if your reaction is SN2, then rate of reaction will be proportional to the concentration of substrate and the concentration of nucleophile. Okay. Now, how do you know this? Or let me put it this way, reverse way. If you have a reaction, we have a reaction which we are studying. In which rate of reaction changes with respect to the concentration of both nucleophile as well as substrate. Then that reaction is having a following SN2 mechanism. Okay, that is following SN2 mechanism. Now, how do you know this? How do you know this? You have to do this in the laboratory. This is a laboratory experiment. what do? You take your alkyl halide, conduct an experiment 1, in which you take 1 mole of Rx, 1 mole of nucleophile. Okay, you take 1 mole of Rx, 1 mole of nucleophile, and now allow the reaction to proceed. After each 5 minutes or 10 minutes, take out a sample. Okay, after each 5 minutes, you take out a sample and find out what is the rate of reaction. Okay, so you get a particular rate of reaction. You can measure this by proper chemical experimentation. Okay, now conduct a second experiment in which you take 1 mole of the same thing and 2 moles of this. Okay, so this is R1. And if you are getting, what have you done? You have changed the concentration of nucleophile. You have not changed the concentration of the substrate. If the rate of reaction changes, if the rate is changing, that means the nucleophile concentration is also affecting the reaction. Okay. Wait a minute. Okay. I got it. I got it. Okay, now, so you have, now the rate is R2. If the rate is changing, that means the nucleophile is affecting the rate of reaction. Now do the third experiment. Change the concentration. You take this 1 mole. Change this, take this 2 moles. Right? And take this also 2 moles. Oh. No. Take this 1 mole. Now what have you done? Compare this and this. You have changed the concentration of substrate. Okay, you have changed the concentration of substrate. And see what is the rate of reaction. R3. Okay. Now, if this rate is also changing, that means the reaction is also dependent on the concentration of substrate. So that means this reaction, rate of this reaction is proportional to concentration of substrate as well as concentration of nucleophile. So if you get such result in which the rate is dependent both on the concentration of nucleophile as well as the substrate, you can say it is a essential reaction. So this is the first characteristic. Right. Now an example, as I have told you, CH3OH plus OH minus CH3Br. No, OH. CH3Br plus OH minus gives CH3OH plus Br minus. So how will you write? Rate is equal to, you know, this is the rate equation. Rate is equal to a rate constant in the concentration of CH3Br now. Can you see now? I hope we can see it now. Okay. Now this is the rate of reaction. Now what is the mechanism? The mechanism is, see this. I write the three-dimensional structure of this molecule. H, H, and H, and Br. Now the OH minus is at the opposite, from the opposite side, the OH minus is attracted. Remember, this is a strong nucleophile. A strong nucleophile. Why do you require a strong nucleophile? Because this will not be easily broken. Okay? This is a strong bond here. This will not be easily broken. You will require the force of somebody from the other side. So the OH minus is strongly pushing it on. So you will have an intermediate stage where, see, this bond will bend to this side. It becomes straight here, and this also will bend to this side slightly and become straight. See that? Now, here the OH bond is half formed. Half. And here the Br bond is half broken. So this is the transition state. Remember, this is not an intermediate. This is what you call as transition state. So this is what you have to draw when you are asked to draw the mechanism of SN2 reaction. This is a transition state. Now this goes, now what happens is this gets bent here, this goes completely off. This will get bent, this also will get bent. I'm talking, this arrow shows only the bending of the, and this bond is completely formed. You can see here, you have O, C, see this, H goes to the back side, reverses the side of the molecule. H and H. Okay. So this is this plus what? Here Br minus. And what is the consequence of this? You can see there is an umbrella inversion occurring here. Okay, an umbrella inversion. What is the meaning of umbrella inversion? I hope you can understand the concept of umbrella inversion. Assume you have an umbrella. You are walking. This is your umbrella. Okay. Suppose the wind is on, very strong wind. What will happen? The umbrella becomes like this initially, and then it goes to the opposite side. You got it? So this is what we call as umbrella inversion. Very similarly, this molecule get inverted. This molecule will get inverted here. Okay. This is very important in the case of the secondary substrates. So this is another fact. Suppose I take a look here. Suppose I take this molecule. CH3. And I got a C2H5 here. And take Br. Now I react this with OH minus, potassium hydroxide, in water, aqueous medium. Okay. What will I get? I'll get the OH here, H here, CH3 coming to the front only, and C2H5 goes to the back. Now we have studied RS configuration. We have studied RS configuration. Can you check the RS configuration here? Look here. Look at this molecule. What is the RS configuration of this? Find out the R. Is this R or S? Let us see. For that purpose, what you have to do? You have to bring the hydrogen to the backside. R or S. So what we have to do? We have to bring the hydrogen to the backside. Let me write it here. I'm writing the same molecule first. For those who don't know it, C2H5, Br. First step, identify the chiral carbon. This is the chiral carbon. Identify the 4 different atoms and groups. I got Br, H, CH3, C2H5. What's the next step? Assign the priorities. Priority number 1, priority number 2, priority number 3, priority number 4. Okay. Now what is the next step? What is the next step? Bring the last priority group to the backside. That means this hydrogen I have to bring to the place of C2H5. So what should I do? I should rotate, replace this here, 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 and here. What will I get? I'll have my CH3 here, C2H5 here, and hydrogen on the backside, and my Br over here. Okay, now assign the priority 1, 2, and 3. And this is 4. Now, from 1 to 2 to 3, it is clockwise, and therefore, this is R configuration. Repeat the same thing here. Repeating the same thing here. I got OH, H, CH3, C2H5. OH is having the highest priority. Second comes C2H5. This is third. This is fourth. Okay. Now again, I have to bring my H to the backside. That means, look carefully. Try to understand that this was studied in the last chapter. This is allowed. So I will write this as OH, carbon, CH3 comes here, and which comes to the place of C2H5? H. And what comes here is C2H5. Right? Now highest priority 1 and 2 and 3 and 4. Yes, the 4 is backside. Now you move from 1 to 2 to 3, S configuration. See that? See that? So this is the characteristic of SN2 reaction. SN2 reaction, the stereochemistry of SN2 reaction. Stereochemistry of SN2 reaction is, see, R is becoming S. And what do you call that process? R goes to S or S goes to R. That process is known as inversion of configuration. Inversion of configuration. So that is if you have a reaction in which if anyway, let us see how far it will go. Yeah. So if you end up with a reaction in which oh my God. I hope you can see the board. I don't. Anyway, there is no much time. Let us see if I can write it. Yeah. If a substitution reaction, if a substitution reaction results in inversion of configuration, it means that the mechanism is SN2. The reaction occur by an SN2 mechanism. The reaction occur by an SN2 mechanism. Okay. I think